This is week 5 course. Last week we ended the section on clean code, okay, and today and next week we will talk about unit testing, okay. And for that, because we work in Java, we will use JUnit. Now, like I said, for if you have questions or you want to say something to your colleagues, just unmute your microphone, say it, can hear you, and you can intervene whenever you want during this presentation. Okay, otherwise, just make sure you mute the microphone in order to avoid, I don't know, surrounding noises or other stuff that can interfere with the audio. Okay, so we start the JUnit part, and the first thing that I want to clarify is why we need the JUnit. It's already implemented by the industry, and this is something you will do it for the rest of your software developer life. Now, in terms of resources, I already uploaded on Slack this book. It's a very short but very specific book. It's written by developers, so it has a practical approach, and the language is technical. Okay, so it's a book that focuses on what's important. And this is the main support for this course and the next week one, especially chapters 3 and 4, the right, be, check, and correct. Okay, so this is the main resource. Now, why do we need unit testing? Because we talk about clean code, okay? And in the end, you have seen that we started with clean code, and I used a lot good code, and we had seen compares between good code and bad code. So generally, clean code and other things that we will do leads to good code, okay? So what's a good code? What are the main characteristics of good code? It's easy to understand. So here, clean code will help us a lot because it's easy to read that code, understand it, and in the end, to change it, okay? So in order to reach that, so you need to write code which you can understand now and later. So in order to do that, you need to understand the problem. After that, you need to design it properly and implement it here, write code and test it. And you see the last word, it's and test it. So good code is not sufficient to be clean or easy to maintain. It needs to be tested. And this is actually the standard today. And this is a movement that started 20, 30 years ago. But you see, 10 years ago, it was still difficult to write code. Okay, maybe the tools were not so evolved as today. The experience of developers, the base of existing software developers was not so huge. So companies, they needed to deal with what they found in terms of human resources. But like I said, today, the number of software developers is increasing. Everybody can code. Remember, they start now at kindergarten to code at some point in Scratch and other visual languages. And so what's the difference today? You need to be more than able to write code. Clean code is an advantage. And in order to close the circle and really to be a professional, like a software engineer, software developer, we need also to test it. And this is because this is what engineers do. When they build a bridge, the main engineer will take a column of very heavy stuff like trucks or a train, and they will go and go through over the bridge in order to be sure that the bridge will not fall down. Okay, so we need to test it. Okay, so in order to complete the circle regarding what means quality in terms of source code, we need to test it. Okay, so we have seen this problem. Okay, this is more related with clean code. So if the code is okay, easy to understand, you don't need to change greater equals with the less than in order to see if that in the end will work. So we want to be sure about this. Okay, so this is like the definition of good code. Okay, so writing code means also writing a corresponding unit test. Okay, now sometimes it's better to start late. Okay, I think I gave you the example with the Romanian internet backbone. Okay, the infrastructure for internet, and that's why we have one of the fastest internet connections in the world because we started late. We started so late when fiber optics were actually the common standard to implement an internet backbone. So we started with the latest generation, okay? Other companies, they started much more earlier, 20, 30 years ago. They have a backbone based on copper, on classic wires, so they need to change that, and that will cost money. And they also need to recover the initial investment and so on. So sometimes it's good to start late because you can analyze what others in front of you have as advantages, and you can focus on that in the short amount of time that you have. So now in companies, you will see two kind of groups. You have very experienced programmers that, I don't know, they started coding 10 years ago, 15 years ago, 20 years ago, when by just coding was enough. And you have the new guys like you, the guys that started 5 years ago or last year, or they will start in the near future. And what's your advantage is that sometimes it's okay to know nothing, because it's like you are a blank book and you can design yourself in the way that you should be now, because otherwise it's very difficult to change the human, okay, the software development, to convince him that what he has done in the last 20 years is not enough. It needs to do other stuff. And once you go over time, you'll see that you will be less open to change. Okay, you will be more and more rigid, and that's a problem with humans. Why I'm saying this? Because unit testing is becoming something that all companies they should do, and not because they want that, because the clients are asking for unit tests, and big companies are asking for unit tests. And for example, if that's not clear, just think what happened with Boeing last year. So you see, clients will ask you for the unit tests. When they will ask you to deliver the project, they will ask the documentation, the source code, and the unit test, because at this point, it's mandatory for companies to do an external audit on your project in order to be sure that you did your job and it's okay for them to pay you. So they will ask for an external audit. And this doesn't mean only check the papers or the documents. It's also mean try to test the component from with others, okay, with another company which has not developed that source code. So in order to do that, they will ask the unit test for that component. Okay, so this is something we will all do, and this is something you can make your own advantage. You can accept that, and this should be your way of working. When you go to a job or into a company, they will say, hey, you need to write your own unit test, and you will say, yes, this is how I learn. And this will be an advantage because there are still not all guys, but guys in company which they don't see the advantage of that. And I don't know, you need to convince them, and you lose a lot of resources in doing that. So where are we in terms of testing? So by doing unit tests, we are not becoming testers or quality assurance engineers. Remember, this is the official name of, because they are still engineers. They have a plan. It's not so easy to just push some buttons. Okay, this is not testing. It's quite a complex stuff to do. So where are we? Are we becoming testers? Okay, software developers have an issue with that. No, because you see, here are the phases that the software product will pass in order to test it, okay, to test the product. So we are quite here at the bottom, okay? Unit tests are tests which are done in the development phase and are done by the developers. And this is the step that some are not willing to take. Why do we need to test our own code? I know I'm better. I'm the best software developer. I don't need to test my code. And this is one of the biggest mistakes that we can do as software developers, to trust on us. Okay, remember, your only friend in development is the compiler, not you. You are the worst enemy because you generally generate all the problems. So we are here. So unit testing is not seen as a Q&A phase. Quality assurance is not testing the software product. Is actually you being sure that what you coded works. Okay, you are compliant with specifications. You cover all corner cases that generally lead to vulnerabilities, very strange bugs, blue screens, and whatever. So unit testing is done by the developers, and is actually the first phase, the first step where you will test something, because this is like starting with the first class that you will implement, with the first method that you will implement. So that's our phase there. This is the moment when we will test our code. So this is the unit testing. Now, from this point on, some unit tests written by us can be used, or the Q&A engineers, the testers, will do their own tests. Starts with the next level, integration testing. So integration testing is like, hey, I'm working on my module, and we start to pile up modules, and the final app starts to take a shape. So we want to test how modules are interacting with each other. Okay, so I want to test the connection to the DB. My colleague has implemented that, so we want to see if through the connection I can get some data and do some data processing. So this is integration testing. So these are tests which will try to verify if modules interact correctly. Now, system testing, we are actually starting to test functionalities that the user will see. So this is like testing the entire system in order to see if it delivers to the user what it needs. Okay, and the last step, the orange one, the acceptance testing, this is the part that your client will do. The real question is how many bugs there are, hidden bugs. This is the real question. But software without bugs, it can't exist. Maybe if you have an application with 2 lines of code, now you can deliver that without 0 bugs. But once you increase complexity, this is an objective that I don't know if someone will ever reach 0 bugs. Okay, so in acceptance testing, the client will want to be sure that most corner cases, more cases are covered. Yeah, they will accept that in the end you will have 1 or 2 bugs, but the idea is that the main functionality of the application works without problems, okay, without, I don't know, trying very specific, very strange scenarios. So acceptance testing is done by the client. So you see, this is closing the circle. You start by writing code and testing your code, and in the end, the client will do its own tests by hiring another company or using its own internal departments for that. And if they will give the okay, then the client will pay you. So this is generally the way things are implemented today. Okay, so this is the entire phase. So you see, we are not becoming testers by writing unit tests, and in the end, the testers are just a phase, because also the client is testing the app. So everybody's testing now the app, and this becomes very, very important. Okay, just think at Boeing and other stories that you heard in the news regarding bugs that they endangered life, or I don't know, generated billions in terms of costs and other stuff. So this becomes very important. Now, another perspective on testing, just to have an idea, because I think can do 1 or 2 additional courses just on testing and how things can be implemented and how you do it, how you implement that. Okay, so in terms of testing, there are 2 types of philosophies. Okay, one is the black box testing, which means when you test something, it's like you have 0 idea about what's inside, or the inner works. It's like you test a phone. So you see the keyboard, you see the screen, you see the soft buttons, other buttons, and so on. So you just interact with the thing, but you can't actually see what's inside. You can't influence that. So this is black box testing. So how do you test your phone? This is what you did when you bought your last phone. You just open the phone, run some apps, I don't know, test some functionalities. This is black box testing. So the black box testing is the perspective of the user. Okay, now what's white box testing? So white box testing is the opposite, and it's also called glass box testing, because it's like when you test the product, you are actually influence the inner works. So in terms of unit testing, this is white box testing. So why? Because we see the source code of the function, we know all the details of the function arguments, what it should return, what are the correct results. So unit testing is a white box testing or glass box testing. And generally, this kind of testing is done by the developers because they have the info, they have access to the source code, okay? They know how the inner stuff of the software product works. Now, in terms of users, they will see only the user interface, the GUI, the graphical user interface, or whatever interface. And if you test your app by that, by using only that, that's called black box testing. Okay. Now, what's regression testing? So why we have regression testing? Because remember, the only constant in software development and in life generally is change. You see what's happening with the world right now. If I don't know, last month I said to you, hey, let's take the course online, and ask the management of the university, they say, no, this is a different form of teaching, okay, because this is change, okay? Now, this has forced us to take different actions without, I don't know, wanted for that or thinking for that. So remember, change is constant in universe. We just need to prepare for it, because at some point it will happen, okay, something. So what's regression testing? Regression testing is about trying to not mess up with something that was already implemented and tested. And this is one of the biggest costs in software development. So you work on a module for 2 months, you test it, everything was great. Now you leave the company and one of your colleagues will take over. And I don't know, 3 months from that moment after you left, they will ask your colleague, hey, try to change something in that module, or try to add new things because the client wants new stuff in it. And your colleague will change something you implemented. And it was okay when you left. So it will change that after 3 months. Now, maybe it doesn't have enough experience. It doesn't know everything that you implemented there. So his changes, with a high probability, will generate new bugs, which maybe they were not there in your module. So he will do the new change. He will add new stuff, change what you already implemented. And after that, something will break. Okay, and you find out, oh no, the client finds out, okay, because you already delivered the module. And this is one of the changes that will trigger the most expensive costs, because you have something that works, you change it and you break it. And it's very difficult to find the cause, because everybody will say, yeah, but this worked, the module worked, so let's look in other places. No, sometimes you just break something without knowing, without being aware. You will break something that was okay, because of many reasons. So regression testing is actually testing done in order to prevent this. And unit tests are perfect for that. Why? Because if I work on that module for 2 months and did my unit testing part, you have, I don't know, hundreds or thousands of unit tests will make anyone sure that my functions were implemented correctly. Now, my colleague will come over this module in 3 months after my leave, and he will change a function which was working and was implemented by me. So at that moment, how can he or she be sure that his or her changes will not break the part that was working? By redoing the testing phase with all the unit tests which are already there. Why? Because the unit test at that moment will assure him or her that the new changes, the new addition, is still preserving the state of my module. And this is regression testing. And this is actually done each night or each week after you commit, or your colleagues will commit, new modules or changes to the existing modules. So you will work on existing modules, you do the changes, you do the commit on Git. They will use Jenkins or other build tools in order to manage the entire process. And each time a new thing is added, they will always run all the previous unit tests. And this is called regression testing. And this will assure everybody in the team that new changes are not affecting modules that were already implemented. Now, if the new changes are based on your specifications, yes, in that moment, you also need to update the unit tests. If you need to change a function the way it should give you results, okay? If the specifications are changing, now you need also to update the unit tests. But if you just want to fix something or add something that was not there, and everything that was already implemented has not changed, based on its specifications. Regression testing is this stuff. It will help you manage the changes that will take place in the future. Okay, so these are the types of tests. So where are we? We are here at the bottom of the, let's say, types of tests. We are the software developers, and this is our part, only this unit testing. It's our job. And it's a white box testing, glass box. Okay, and based on unit tests, we can do regression testing. Okay, so regression testing generally means rerun all the tests each time a change has been implemented in the project. And this is entirely based on unit tests and other tests, depending on what the QA, the quality assurance engineers or testers will use as a framework. Okay, so let's resume and start the JUnit part. So what's unit testing? It's a simple and rapid method to test the source code. So as you see, for the programmers, once again, I highlight this. Okay, it's for the programmers. Okay, it's an instrument for the programmers. It's used in the development phase. 5 years ago, the companies, they were investing a lot in trainers or external trainers just to bring them on in their software developer teams in order to convince the existing software developers that they need to do unit tests. Like, why do we need to do unit tests? Because these are the advantages. And in order to avoid the heads-on discussion with the manager, they will hire external trainers or consultants, and they were prepared to answer all the questions why we should not do this, and they are like trying to convince everybody else that they should do it. Okay, so now things have changed, and like I said, for you this is a good thing, because if you start with this perspective, you already have a competitive advantage over the others. You are already prepared, and you accept that your job is also to write unit tests. So that's why I repeat here for programmers in the development phase. Now, what's a unit test? Because it's written by developers. It's a sequence of code, once again, written by the programmer. Okay, and so it's a function that you will write. Okay, so it's, once again, it's our job to do that, because this is the job of programmers. Okay, to write functions, not of a tester. Okay, now a unit test assesses or verifies. We will use this word a lot because this is actually the function that we will use in all our unit tests. Assess. So this is the equivalent of saying you evaluate, you verify, you check, whatever, but we will use assess because it's actually the keyword in JUnit. Okay, so we will assess how methods run in well-defined context, which means if I'm giving to that function, if I call that function with a specific set of input values, I expect the result will be that. For example, you have a function that adds two numbers, 2 and 3. So if I call x and y, sorry. So if I call the function with 2 and 3, I expect that the result should be 5, right? 2 plus 3, 5. Okay, and once again, like I said, you have another course in parallel with me, with this one, something like designing and implementing information systems. And then you will talk about agile, Scrum, and whatever. Now, unit testing is part of TDD, which is test-driven development, which means write unit test, implement the function, test them, and so on. I have a slide on that, and this is part of Scrum as management philosophy for software projects. And another philosophy or technique is BDD, behavior-driven development. Okay, and it's also using unit tests. Okay, so you have these two, TDD, BDD acronyms. Okay, so this is a short introduction on TDD. This is the definition from Wikipedia. You have the slides. So it's a development process that relies on repetition of very short, okay, and so on and so on. Now, this is the logic flow of TDD. So this is how we should write our software based on TDD and unit tests. So when you get the specifications of a function, you understand the specifications, you define the function signature, and you define an empty or a mock or a stub, which means you have a function that is doing nothing. So let's try to implement a function that adds the values of an array. Okay, so we have this function, so how this should go on with TDD. Okay, so I will create very fast new Java project. So this is course 5. Okay, course 5. And let's add the faster package. package, new package, raw.asse CTS, CTS. Okay, so this is course 5. Okay, so, and here I will add a class, a very simple class. Let's call class math methods. Okay, for different stuff. Okay, finish. Let's not go for a math methods. I will rename it. Let's say my collection. Okay, just to have my collection. Let's rename the rename file to my collection. Even more, my int collection. Sorry for that. Okay, so here we will have an array list of values. Okay, array. Yeah, IntelliSense is failing on me the first time I'm using. Okay, integer. Remember, in generics, in Java generics, you can't use primitive types, so you need to use wrapper classes like integer, double, float for the primitive equivalent. Okay, so this is values. Okay, I don't need the number of values because I have it. Okay, and let's generate constructor using fields, even if it's not the perfect constructor that I'm thinking of. It's getting the array list. Now, here you see we have shallow copy, which is not okay, because I'm sharing the same input values as the external module. So who is calling me is passing me a reference to an array list, and I'm sharing it, which is not okay. Because if they change the values, they will change my values. Okay, so this is one problem here that if we are not aware, we will have issues with it. The shallow copy. Okay, so yeah, we will have a condition to help us find this bug because this is not normal. Okay, now let's do a function int which will compute the sum of the elements there. Okay, so everybody I think will implement it like this. Let's say this is the naive implementation. Now TDD says this: when you write this, you understand what are the specs. It's like you have a function called getSum, returns the sum of your values, okay, and it has 0 input arguments. So we just received the specification, we understood them. So in TDD, you just define the function signature, and in order to compile this, you obviously, because you will have a compiler error and you can't call this one, you will have return 0. Okay, so this is TDD. You just do a mock or a stub of this function. You just define it, and this should be the first thing. Now, how do we test it? So we need to write a test. Okay, and how do we write a test? Okay, now in order to do a test, you may think of this. Let's add a new class. Let's say test up. Okay, I will check public static void main. So how do I test my function without knowing about frameworks which are dedicated to this job? I will do this: create a my collection, I don't know, collection 1, or just collection equals to new my collection. Now here I need some values, so let's define them. Array list integer. Okay, values equals new array list. Okay, and let's add some values. Values add, I don't know, 10. Multiply this line. So 20, 30. So in order to test it classic way, let's say without JUnit or other dedicated frameworks, I will create my collection, pass the values. Now I will do something like int sum equals collection dot get sum. Okay, and do this if sum equals 60, it works. Okay, else system out print line, Houston, we have a problem. And we run it. So run it. Houston, we have a problem because the output is not sum, is not 60. So in this case, I will want to have more details. Houston, we have a problem. Let's say the actual sum is values, and let's concatenate the value. Something like this. Let's rerun it. So you see, Houston, we have a problem. The actual sum is 0. So right now, we need to check what's the problem. Obviously, you already know the problem. The function is not implemented. This is like TDD. You define the function signature. After that, you do a test. You don't implement the function. The function should be implemented. Then you just want to test it. So it's like, let's test the function for 3 values. Let's see if the sum is 60. You run the test. The test will fail, obviously, because you have only the header. And now you go back and now you implement the function, or you fix it, because later we will just fix it, in order to be sure, in order to make the test pass. So we see the problem. We have returned 0 by default. Let's implement it. So int sum equals 0 for int value into these values. Okay, sum plus equals value, return sum. Okay, so go back again, run the unit, the test is not a unit test, it works. Now this is TDD. Now you do another test. For example, what will happen if you have an overflow? What will happen if you don't have values inside the collection, or the reference is null? And this will be covered by the right beachhead correct discussion. So this is TDD. You see, you always start from scratch, write a test. If the test succeeds, write another test. If the test will fail, and this is what you will hear in different presentation, or read in different books. This is a common practice. When you implement unit tests, write unit tests that will fail in the first phase, because failing, it will alert you that you forgot or you have a bug in the function, and that will force you to fix the function. So generally, you write tests to fail. Okay, you are, let's say, you become your worst enemy. You want to prove yourself that you are a lousy developer. So when you write unit tests, you write them against you. So write them in order to fail. Now, if they don't fail, that's a good thing. But generally, you will see corner cases and they will fail. And this is TDD. Okay, so check if the test fails. The test fails, write production code or fix production code, run all tests. This is the regression testing. Run all existing unit tests each time you do a change. If another test will fail or another fail will test, once again, change the production code. Okay, and if all tests succeeded, do the refactoring and other stuff that will clean your code. So this is TDD. Okay, and this is one way of writing source code today. And this is the cycle of TDD. This is why I said to you, write unit tests that will fail. Okay, start on red, fix the function, refactor. This is the clean code. When you refactor, improve the source code, I don't know, reduce the size, implement solid and other stuff. But generally, write the function, write the unit test before writing the function, or write the unit test before trying to cover a corner case in that function. The test will fail, go to the function, fix it or implement it. If the test passes, refactor it. Okay, it's like we did at the seminar last weeks. Don't try to write the function with solid clean code in your head at the beginning. It could be too complex. So just write the function and fix it or improve it later, refactor it later. Okay, just focus on the algorithm, and after that focus on solid and other stuff. This is another logic scheme for how to implement TDD or how to use unit tests. Why to use unit tests? Because I already give you a lot of reasons. This is the problem with, and we covered that when we talked about clean code. These are actually the forces that will make us write bad code, and we know what are the problems with bad code. So these are the sources of evil. I think this is like always, you will never have the available or the desired time. We are always short on time. Deadlines are too short, and so on and so on. And the budgets are not infinite, are fixed. So they will impose a deadline at some point. Don't have the necessary experience. In time, you will gain that, but your new colleagues each time have less experience than you. Just think at you or of the guy that in 5 years will join your team and it will be a graduate like you today. Okay, so there is very difficult to have a team with the same experience level and to find new guys, new people with the same experience. Okay, it's very difficult. So they don't have the same experience levels. Okay, now the programmer know-how, which means that's why never stop to read, to improve yourself by reading about new ways, new techniques, new patterns, and so on. Specifications, we know they are not always in the way they should be. Okay, maybe they are not written by us. Complexity of the solution and so on, and the rate of change. Remember, change is constant. Now, in terms of bugs, this is another reason for using unit tests, is that this is the cost of fixing a bug. This is an old study, but the price is, if you update them by taking inflation and other cost factors, you can update them to today's costs, but the graphic is still valid. So, and it makes sense. You see, let's suppose this is at 1996 level. So this is the number of bugs that are generated in different phases of development. So you see 85% of bugs are generated here in the development phase when you code, because functions will do what you want or what you implement. So if there is a bug there, it's generated now. Okay, now the cost of fixing bugs at this level is very low because this is something you implemented last week, yesterday, today, or last month. Let's say the memory is fresh. You know what we are doing, what you are supposed to do. So it's easy to fix bugs here. So let's say that's the price, an average price per bug, $25. Now, how do you compute that? Is the amount of time that you need to fix the bug. So based on your salary, your wages, they have costs per man per hour. So if you spend 3 hours to fix that bug, that's the cost. Okay, it's like they will pay you for 3 hours just to fix the bug. So that will be the cost of that bug. Suppose this is the price. Now, you see, when we do unit tests, from that very high amount of bugs, we reduce the amount of bugs that remain in the source code or in the software product almost to zero. Now, like I said, it's impossible to reach zero, but you reduce that amount. So it's like, that's the effect of unit testing. Will help you reduce a huge amount of bugs that you, without knowing, based on lack of experience, whatever, you generate. And it's natural to generate that. So you see, unit testing is helping you fix that number of bugs, okay? And also it's increasing the number of bugs which are found at that moment, okay? You code, you unit test, you find a lot of bugs and you reduce a lot of them. Once you move away from coding, you see after release, you have the highest prices because you don't know what's the impact. So the prices are huge here, the costs are huge. You can also lose the company because of that. This is the advantage of unit testing. It's helping you reduce this amount of bugs here and actually their costs and so on. This is a graphic that will help you see the effect on bugs on the development costs. Why to use them? Should be final arguments, because they are easy to write, and we will do that. It's very easy to write. You don't need to test the entire code. You just need to test the things that, let's say, are complex or you think they will break in the future, or you are not sure about their implementation, okay? And also follow this rule. And this is something you as a manager, maybe in 3 years, 5 years, 10 years, you will use in order to manage your budget. So you see, generally, this is the 2017 zero rule, and it's actually used by management. So generally, when you ask your developers to write something, just take into account that in order to write that thing and to write unit tests, they will spend some time, and generally in time it's quite substantial. So if I need 2 or 3 hours to write a function, generally I need at least 3 hours or even more to write the unit test, because when you write the unit test, you write multiple functions testing that unique function. So the amount of source code generally could be bigger than the initial function. And you need to think at different corner cases. So generally writing unit tests, yeah, it's costly. That's why some software developers, they have an issue with that, okay? Because they take up their spare time, let's say. Now, when you write unit tests, and this is the management view, they should make part, or let's say 20% of the development time. Now, this is overall, because remember, when you develop a function, you code only 10% of the time, 90% you read specifications, you think to different algorithms, whatever. So 20% development time means the overall time. So if I will assign you 1 month for a module, I will think for that from 1 month, you will use 1 week or something like this to write the unit test, okay? So this is 20% development time. Now, 70% code coverage, we will cover that. Now, code coverage means if you write the unit test that tests a module, and the module has 1,000 lines of code, how many lines of code in that module have been executed by the unit tests? Which means the unit tests are covering how much of the source code of the things that you want to test. So if you cover from 1,000 lines of code, functional lines of code, 700, and run all the unit tests, it means you have 70% code coverage. If you cover 900 lines of code, you have 90%. And if you cover all of them, you have 100% code coverage. The unit test, in order to be sure for a management, for the lead or for the client, that are significant, you can write 1,000 unit tests which are doing nothing, and you have code coverage 0. Now, you may say you have 1,000 unit tests, but they have 0 added value, okay? They are useless. So in order for the client and the management to be sure that the unit tests are actually doing something, they will check the code coverage. Now, today in industry, clients will ask for at least 85% or even 90% code coverage. This is for common software projects. For sensitive software projects like brakes, you are developing the software for the brakes. Now they will ask for even higher degrees of code coverage, like 95%, 96%. Now, sometimes it's impossible to reach 100%, but they will want to be close to that. Okay, so this is the code coverage, and I'll show you how Eclipse is computing the code coverage. Now, remember that we are writing only 10% code, so they will help us in the development phase. Okay, you see here other reasons. Some of them I already specified. Now, this is the last reason that I will use to convince you. Test promotes implementation of clean code principles for writing code. Why? Because if you write bad code, you write very ugly spaghetti code, whatever, very complex functions, it will be very difficult to test them. It will be so difficult to write the unit test, which in the end will force you to refactor and clean the function. Because if you have multiple results computed there, it will be very difficult to write a unit test for which result, and so on. So in the end, by writing the unit tests, it will help you see yourself from a different perspective, because you need to test what you have implemented yesterday. And if that thing is not clean, is bad, the unit tests are difficult to write. So it's like you are becoming your most vocal adversary, because it's like, why I have written that yesterday? I need to refactor it. This is another reason, because unit tests are something that you will not like to do. You will want to write simple unit tests just to finish the job, and that's it. Move to code, to once again to code new stuff. That will force you to be clean when you code, okay? Because the unit tests, otherwise the unit tests are difficult to implement. Why not to use unit testing? Because of this and other 1 million reasons. Okay, these are the stuff that generally software developers are arguing. Why do they need? Now, let's say this is not for babies, okay? In order to close any argument, yeah, it's hard. I don't know how to do it. Okay, it's not. I know that my function will always work. I proved that in the last 10 years, and so on and so on. Like I said, let's say it's not for babies if they don't want to do it. So we know what's bad code, okay? confusing, and so on. This is another definition of bad code, and we have seen that. Fast, rapidly developed code, deploy code slows you down. Because, like I said, it will slow you down in the future, okay, when you need to change it, when you need to unit test it. Remember the technical debt discussion, okay? This is a very important concept in clean code and software quality. This is the process, and we already covered TDD. So this is like a summary of the process that you will go through. So this is you write the unit tests, implement the source code and test it, correct your code. This means refactor it, implement clean code principles. Others will do a code review, and we did that at the laboratory in order to be sure that the clean code principles are there, or the code is clean, in order to tie up the team, so on. And also they will do regression testing in order to be sure that you didn't broke something that was already working. Now, this is the build automation phase. So you can use Jenkins and other tools. You will run automated unit tests and regression testing. They will do a unit test coverage analysis, and they will block your merge request if you don't pass these minimum requirement levels. So if you don't unit test your code and provide at least, let's say, 70% code coverage, the merge request will not be accepted, will be rejected, because you didn't unit test your code. So these are already implemented in the build automation phase, sorry. And now after that, you will get the okay to merge your code. And after that, these are the Q&A department job. These are the testers role. They will do functional integration and other tests. Okay, so this is where we are in the environment. So how to implement unit tests? Read the specs. If we don't understand the method, what the method is doing, which are the input arguments, what the result should be, obviously you can't write it and you can't test it. Okay, so this is the mandatory part. After that, we write tests to fail, like we just did with the previous example. Okay, here. So I have written a method. Initially, the method was a dummy one, return 0. I have implemented the test in order to see if is computing the sum of 10, 20, 30 correctly. We tested that. We have seen we have a problem. The sum was 0. We went back here and we implemented the function for this, let's say, normal case. Okay, and after that, we run the test, and now it works. Okay, so this was the phase. And if at some point something is wrong, go back and redo the function, read the specifications, and so on. So what do we test? This is actually the course about. Now, the laboratory will focus on syntax and implementing these conditions. Now, what we want to discuss is, what do we test? The JUnit framework is easy to understand. It has a simple syntax. It has, let's see, I can jump in the future, let's say. This is the description of the JUnit framework. I think it's JUnit 3. So this is all. This is the entire framework. I think you have, what, 10 classes or less than that. And they are all. And we are actually using less than what you see here. We are using the test interface. We are using the test suite. But what you see on the left side, the base test runner, the test runner, this is actually when we run unit tests. You don't actually see that. So, or the test result or the test listener. So it's a very simple framework to use. Okay, don't worry about this. You have this function which we already implemented. Now it has a different argument list. What do you test here? You need to write some tests in order to be sure that the function has been implemented correctly. So one test is what we already did, is like testing the sum of the values for 10, 20, 30. Okay, so let's say this is a normal test. Now, what else would you test? Okay, so normal values. Okay, normal values will be one. Let's put it here on the side. So for this function, what else should you test? Okay, so one will be normal values. Okay, second, if the array has values, which means the array exists, but it doesn't have values, right? It's like an array with 0 values. Okay, other number is positive, right? Anything else? If the actual result fits an int, right? It's like we don't have an overflow because an int is limited to 32 bits. So we can add into that a lot of values, but at some point the result will exceed the maximum value that we can store on an int. Now, other conditions. Okay, because we have the redundancy, now that design. So if number equals the size of values, right? Okay, yeah, if values is different than null. What will happen if we receive a null reference, right? So by just looking at this function, we can determine things that we should test. Okay, now how can we be sure that we cover all corner cases? So we need a methodology, we need blueprint that will help us define questions based on which we can do some tests. And actually, by doing these tests, by just looking at this simple function, we realized now that all these things are not verified inside the function. So if we do these actual tests, I think for most of them, it's clear, without actually writing them, that the function will fail, the test will fail. Why? Because you see, what will happen if we pass null here? So we will have a runtime exception here. When you have result plus equals values, this is a null reference, you'll get a null pointer exception. You'll have a crash instantly. If number is not equal with size, I don't know, very strange behavior. Maybe you have a values array with 10 integers, but their number is actually 5 here. So you will add only 5 of them. And you are not aware that you have 10 in the array itself. And you see, all these tests will fail because this is the way we wrote the function, as simple as possible by just thinking only at this. So we normally implement functions by thinking only at the normal case. And this is our biggest disadvantage. We tend to simplify things. And generally, that will be our first version of the function. And now the unit test will help us see the function from perspectives which are not, let's say, normal for us, because we are optimistic, we know we are good, and so on. So all those perspectives are actually our blind spot. They are not helping us see the real stuff. They are actually hiding future bugs. So how can we create a methodology for this? How can we be sure that we cover all these cases? Now, in the presentation, based on correct, these are the unit tests that we should do, and it's covering most of the things that you already said. But you see, there are actually 9 corner cases here. Okay, and in the end, if you go through all these 9 tests, and generally they will fail because no one has taken that into account here. We focused only on the normal case. This is how the function will look like. So it's very difficult to write that function like this. No one has written that. Remember how many times we asked you to write a function that computes the sum of an array elements. Now we have a different perspective. So you see, based on those tests, which are assessing 9 different corner cases, 6 of them you already specified them. This is how the function in the end will become. How do we reach this? Now, in order to be able to find all the conditions, that's why I recommend you that book. We are following the, let's say, the classification of conditions to test based on the pragmatic unit testing book. You have them here. So you have correct and right BJEP. Now, both classifications are overlapping. More than half of the conditions are similar or are the same, but they have different names. So this is correct. And why it sounds okay? Because correct actually contains the acronyms of the conditions that we should check. And these are called correct boundary conditions. And generally, they look at the input data. They all look at the input data that your function receives. And based on that, you should do some tests covering these corner cases. Now, so correct has conditions that you need to check for functions that you implement. Now, sometimes it's not possible to test all conditions because that depends on the function specifics. Maybe it doesn't have a reference type input. So in that case, you can't do existence or reference tests because you don't get a reference, okay? So these are, let's say, universal, but sometimes, depending on what functions are you testing, you can't apply all of them, okay? You are limited by the function itself. So what correct means? Means conformance, ordering, range, reference, existence, cardinality, and time. So let's go through them. You have examples in the book describing each condition. I will just go through them. Now, if you need more details, you can go and read the chapters on that. So let's see. Conformance. This means, has the value the correct format? Is the value valid? Which means if you have a function that receives string value and you have a setter for a name of a student, have you tested in the setter that the value it's formatted correctly? It has at least 3 chars. It has, I don't know, for an email, it has a dot, it has a domain, it has the @ sign, and so on. So this is the first thing that you should test. If the function checks if the values are conformant, if the values are based on specifications. So always check the input values if they are correct. Now, if they are correct, the function should behave normally. Otherwise, what it should happen if the values are not correct? What you should do if you implement the function? What you should do if you receive a value which is not correct? Exactly, throw an exception. This is what the unit test should check. If the values are correct, the results should be correct. If the values are not correct, generally you should expect for an exception. Now, ordering. The set of values must be ordered or not. This depends on the function. For example, if you are doing a sorting, have you taken into account that what your function will do if the values are sorted, are already sorted? Have you covered that? Maybe your algorithm has a bug, and this will help you find it. So you see, if the function will get an array of values, if the order matters or can influence your algorithm, for example, you determine the minimum or maximum, and this is a common bug. Everybody starts with 0. Okay, you should always start with the first value in your array and so on. So ordering means, have you considered that the order of the values that you receive may influence or not your function? So this is ordering. So for a sorting algorithm, do a test with a set of values which are already sorted, so the function should not change their order, or pass a function which passes a set of values in which the values are sorted in the opposite. And now the result should be a new array or set of values which are now sorted. So you see, this is ordering. Now, range is the value between acceptable limits. For example, you have a student class with an age, and based on specifications, they will tell you, hey, the age should be between 10 and 90 years. So have you considered that? Do you do validations? So do some tests with values inside this range from 10 to 90, and do some tests with values outside the range, in which case the function should return an exception. So range always should help you ask yourself this. Hey, what's the value? What are the accepted ranges? What the function will do if I pass a wrong value based on range? Okay. Now, here another thing that you should test is always test the limits. Because if I say to you the value is, the accepted age is between 10 and 90, including 10 and 90, you should always check 10 and 90. These are called boundary checks. Because you may have a programmer which is doing a validation, and instead of writing greater than, greater or equal, then it may implement greater. So by mistake, he or she will not accept 10, okay, because he misunderstood the specifications. So always do test on border values, okay, just to find this kind of trivial bugs. Less instead of less or equal, greater instead of greater or equal, or something similar. So this is range. Now, reference. Reference means if you receive a reference, have you tested for null? Okay, do you got something there, or you have an empty reference? And secondly, if you receive a reference, do you do shallow copy? Is the change of the external set of values are changing your values? And this is the most important test for references in order to avoid shallow copy when you don't want to do shallow copy. And you see, this is the test that I should do here in my collection, because here I'm doing shallow copy and maybe I'm not aware of that. So a reference test will do what? Pass me a set of values, 10, 20, 30, do the sum. It will be 60, right? Now change the values outside of your function. So for example, you see here, I can change the values, the second value inside values. Okay, let's change it to 90. Now let's do the sum again. If the two collections are independent, I'm passing your collection, but you do a clone of it, you create your own copy. It means that if I change my external set of values, that should not affect you. Okay, so by changing the second value to 90 after I pass it to you, your sum should still be 60. But if it's not, it means you have zero control over your values. So this is the reference condition. Okay, always try to check this in order to avoid shallow copy if that was not intended. Now, existence. This is actually the null reference. Or if you receive a reference, always test if that exists. So this is like testing for null, what you already said. Test if values is null before trying to do the sum. Okay, so this is the existence. Now, cardinality means this is a mathematical property of the set of values. So cardinality is actually the number of values inside the set. So cardinality 0 means you have the set, but it has 0 values. This is like an array list with 0 values in it. The array list pass the existence because you have a reference to 1. But for cardinality 0, it means what do you do when you compute the average? It will work because you have the array list, but the values is 0. So do you do a division by 0? Because the size is 0. So cardinality always force you to do some checks depending on how number values do you have in the set. So here the common tests are for cardinality 0. The collection exists, but it has 0 values. 1, what will happen for 1 value? 2, and more. Okay? So generally, these are the tests that we will do. And time is the performance. So maybe you have some restrictions. Your sum function should compute the sum of 1 million values in less than 1 second. This is the time test. So when you have performance restrictions or constraints, you need to do unit tests by trying to go for the worst case scenario and measure the time. So in that case, you need performance tests, which are actually unit tests or tests that will measure the amount of time that the function needs in order to compute the result. And for some clients, some products, you also need to do this. So this is correct. Okay, and this is how we, I don't know, use this classification. And here you have different examples for it in order to be sure that we covered all possible conditions. Okay, in order to be sure that we try to cover everything. So that's why we will use correct. Now, right Bishop is the same, and this will be my ending comment for today. So right Bishop stands for right. So are the results right for the right input? This is, you may say, it's actually conformance. Yes, it's similar to conformance. So if I'm passing you right values, the result should be right. Okay. B, this is the B here. Are all boundary conditions correct? Now, B here is like for range, trying to help you focus on boundary. Like the example for the student age. Always check 10 and 90. If the specifications are actually saying that 10 and 90 are valid values, okay? Always test them. they are the boundary of the correct values range. So range is like try to test values in the entire range, correct values and not correct values. But boundary here, the B from BChep says always test your boundaries, the limits, upper and lower limits. Okay, so you see these are combined. Now, inverse relationship is like, can you check the inverse? Which means if you do a test and the result should be positive or true, can you check the false condition? Which means, can you prove that the function works by actually showing that for certain values is giving you false? And I don't know, doing a mathematical deduction, it will mean that for the other values it will work. Okay, now we will discuss more next week on this inverse relationship, because we have seen that it's I don't know, kind of difficult to understand. Cross check means use other functions. Maybe you have a complex algorithm. How do you check if the results are okay? I don't know, you use MATLAB or you use another library in which you trust, and you use a similar function there with the same data, and now you cross check. That's why you have the name here. You cross check the results, because the computation is too complex to do it by hand. So you need to trust in another library. Can you force error conditions? This is the here. Now, generally, this is throwing exceptions. So if I pass you wrong values, you should throw exceptions. And performance is actually the time. Okay, the T from correct. Okay, so these are the two categories of conditions that we will use. And next week we will insist on them, and we will take some methods, and I will go through all of them, and we will discuss them again in detail. This is actually what the unit testing part. The biggest problem that I have seen is that you need to accept it, and that's why I try to sell this idea to you in the first part of this course, to show you the advantages. Now, companies fortunately will force you to do it, some companies, but most of them are doing this because their clients are asking for that. And in terms of unit testing, is more than accepting the philosophy and trying to have a different perspective on how you write and test your code. And in terms of syntax, you will see that in two labs, you can learn the syntax specific to JUnit 344. It's very easy. The biggest problem is, okay, what do you test? And for that, we will use the right BChep and the correct classification, just to have a guide, okay, just to speak the same language, okay? So that's why, because otherwise we can be very subjective, okay, in describing. So this is the intro on unit testing, and next week we will take some functions. I will give you the code, and we will try to have an open discussion on correct and right BChep on those functions. See, you have slides here. You can go through them, but the seminar is helping you do this. You have a short intro on JUnit 3. So the last 20-30 slides are on the syntax, but I will not cover it because you learn it by using it, okay? It's no added value here. So you will do that at the seminar. And at the exam, like I said, you can use JUnit 3 or JUnit 4 or JUnit 5, the Jupyter, is the last version. So that's why I'm not insisting in a specific version, because in the end, you can choose your own version